Hello, I'm Mayank Chauhan, Product Line Manager for our Converged Packet Optical portfolio. Today we will demonstrate how Ciena's Coherent ELS, seen here behind me in the lab, delivers high-capacity coherent DWDM to the edge, including 400 ZR applications, all in a compact, hardened form factor with unprecedented operational simplicity. Ciena's Coherent ELS is an open line system designed to address the evolving requirements for the photonic layer at the network edge. With ROADM-like operational simplicity, ELS brings 100 gig to 400 gig coherent wavelengths to the edge, all in a compact, temperature-hardened form factor with 100 gigahertz channel spacing. It supports flexible configurations, including point-to-point, linear, and hub and spoke. ELS features ROADM-like embedded system intelligence and automation that is unmatched in edge photonic systems to simplify turn-up, system optimization, and management. In this demo, we will introduce an overview of the Coherent ELS platform. ELS introduces two new chassis, a single rack unit OADM, available in either 6 channels or 10 channels unit, and a 2-rack unit terminal supporting up to 48 channels. Both the OADM and terminal chassis offer flexible dual-feed AC or DC powering options and support front-to-rear airflow with a removable fan unit that is easy to replace in service. The OADM is a temperature-hardened, enabling for the first time coherent line system deployments in uncontrolled environments, including outside plant cabinets. The chassis are equipped with status LEDs that provide an intuitive way to quickly verify error-free installation. Additionally, both chassis are equipped with a DCN and a USB-C console port and 7 RJ45-based DLAN ports. In this demo, we will demonstrate how fast and easy it is to install ELS. When removed from the box, the chassis, in this case, we have an OADM, but the same would apply to a terminal, has brackets already installed, which makes it easy to quickly rack and stack on the shelf. ELS is designed for fast, high-scale deployments and features a stackable plug-and-play design that reduces fibering complexity through the integration of various components within the chassis. It only takes a few minutes for a single installer to rack and install the chassis. Once it is installed, the installer simply has to connect the power and DCN port along with the line system fiber and the express fiber in case of an OADM site only, and you are good to go. Today, we will walk you through some of these demonstrations. Demo 1 will show you automatic system turn-up capabilities. Demo 2 will show us adding a 400 gig wavelength, including 400 ZR wavelength on top of an existing ELS line system. Demo 3 will demonstrate the fast remote in-service troubleshooting and real-time power monitoring capabilities built into the ELS line system. Now we will demonstrate how ELS supports automatic system turn-up capabilities, ensuring error-free on-site installation. The front of the chassis is equipped with intuitive LEDs for instant verification, confirming all connections are valid and that the system is ready for operation. Our demo system consists of two 48-channel terminals labeled as Terminal A and Terminal B. Before adding a configuration file on either Terminal A or B, the status LEDs are yellow, indicating that the line fiber is not yet connected. As soon as the line fiber is plugged in, the OSC link is established and status LEDs turn green, showing that the bidirectional link is operational and ready to carry traffic. Now we will show how Terminal A is commissioned. To enable remote management, the installer connects their PC to DCN1 port on the chassis, and to log in locally to box, and the configuration script file is loaded on the system to configure the IP address. We have executed these same steps at Terminal B, and from this point on, everything can be done remotely. ELS leverages embedded system intelligence that includes power monitoring capabilities. As shown here, we can see the supported loss and the span margin. As we have communications established via OSC, on the GUI you can see the neighboring node, which is terminal B. Now that our ELS line system is up and ready to carry traffic, we can add some wavelengths. As we have no wavelengths deployed, we can see on the ELS GUI that no powers or frequencies are visible. We will demonstrate the addition of two 400 gig wavelengths across the line system. The first wavelength leverages Ciena's 5166 router at both ends. The 5166 is equipped with Ciena's WaveLogic 5 Nano coherent 400 ZR QSFP DD pluggable, enabling coherent 400 gig DWDM applications. We have already connected everything at terminal B, but not at terminal A. As expected, the 400 gig client test set indicates an LOS. And as we connect the LC fiber to the terminal A, the test set shows green, indicating that the 400 ZR wavelength is now being carried over ELS. The test set is green, indicating that the 400 ZR wave is being transported successfully over the ELS line system. The second 400 gig wavelength is coming from our Wave Server AI platform seen here, where we have a 100 gig client service running over this wave. And we can do this addition without impacting existing traffic. Again, you can see the test set is red, and when we connect the LC fiber to terminal A, the test set shows green, indicating the 400 gig wavelength is now successfully being carried over the ELS. We will now demonstrate the ELS operational benefits that enable faster remote troubleshooting, starting with line system fault. To show this capability, we have a variable optical attenuator, or VOA, in the line and the receiver direction of terminal A. We can verify supported loss and span margin under normal operating conditions, as shown on the top right-hand side of the services view that correspond to the line ports. As we increase the attenuation on the line, ELS tracks changes in the system fiber loss, and we can see that although we have no alarms, the margin is decreasing. As we continue to increase the attenuation, the margin continues to decrease, and we get a minor loss margin degrade alarm. If we continue to increase the attenuation, we eventually get a major loss margin fail alarm. When the system is restored, it automatically recovers. We will now demonstrate how ELS can monitor the power of a specific channel in real time and can raise an alarm when it's outside of the optimal range of operation. To show this, we will increase the power of the 400G Wave Server AI wavelength on terminal A. The operator can select different high and low channel degrade thresholds. As we increase the power of the wavelength, we can monitor the channel margin and we get the corresponding alarm. Thanks for watching. With this demo, we highlight how Ciena's coherent ELS cost-effectively addresses the evolving requirements for the photonic layer at the network edge, delivering high-capacity coherent DWDM, including 400 ZR applications, with key differentiators that include increased automation, intelligent optical control, and remote management, enabling fully automated deployments with continuous system optimization.